sections, and they will say on the AP test, find if the cross sections are squares, are circles, or whatever. But now we're just doing actual revolutions. So here's our steps. So how to find the volume by the slicing method is what's called, or method of slicing. So this is called the slicing method. First things first, draw a picture. Draw a picture. I can't even tell you how important this is. In area, we're going to go over those quizzes finally today. Some of you had the wrong area, which means the whole problem was wrong. Same kind of goes for these volumes. If you have the wrong section that you're revolving, the whole thing's going to be wrong. So it's very important to spend a lot of your time on this part. The actual integration should not be too tough. It's setting it up should be the hardest part. Find a formula for a of x. Now we know if we're revolving, my formula is automatically
circle.
So my formula is pi r squared. Find your limits of integration. Sometimes you're told from x to this, x to that. Other times you have to do your intersect command and all that good stuff, just like here it is. And then finally, integrate. Integrate a of x to find the volume. So it's just like we did yesterday, only now we are revolving. You're not told what shape it is. But revolving naturally creates a circle. Like, have you guys seen those decorations for holidays, like, you know, Halloween, Christmas, baby showers and things, where they're flat and then you fold them out and they're like crinkly all the way around? And they kind of look like a filter, a pool filter or something. I mean, that's exactly what's going on. We take a two-dimensional shape, we uncrinkle it and roll it around like connect it and it makes a pumpkin or something. That kind of decoration is what's going on. Okay, here we go. Today we're going to focus about revolving around the x-axis. So this first one, we're revolving around the x-axis. Why am I thinking this was an error last year? I don't know. We'll find out as we get into it. I wonder if that was supposed to be square root of 3 times x or square root of 3x. For some reason it's just popping out in my brain like something's wrong with this. I don't know. We'll find out. We have the region between the graphs, square root of 3x, y equals 0, and x equals 4, revolved of the x-axis to generate a solid. We're going to find the volume. Okay, first thing I do, picture. We should know what square root of 3x looks like, correct? Looks like that, right?
Yep.
Y equals 0 is really the x-axis, and x equals 4 is this line. You with me there? I'm going to label some of these. Now this is just the area right here. That's my two-dimensional area. That is bounded by those regions. Does everyone agree with that?
Yep.
So what I'm going to do, I'm going to pick that up and revolve it all the way around. So picture-wise, it's going to look like a tornado. Yeah, exactly. It's going to look like this. And we're going to draw those circles here because it is, well, like Forrest said, like a tornado. Those are my cross sections. That's what your solid should look like. Can you picture it in your head? So I'm Some kids about said kind of like a bullet kind of thing is what this one looked like. If I drew it a little better,
Yeah.
that's what it would look
I
like.
can see it.
Okay, so I've got the first part done. I have sketched the solid in a typical cross section, which is a circle.
It's the Mario Kart.
What?
Big black. It's the Mario Black Bullet thing.
I have no idea what you're talking about.
The face and it's got like the big.
Video games are banned in my house. Yeah, never
It's like
played
the
them.
sweetest thing to get.
Never
You get
played
that.
them. My mom hated video games with a passion. And then
You learn a lot.
I went home one day in college when the Wii first came out, and they were really hard to get. I walk in the house at Thanksgiving, she has a Wii sitting up on her. I'm like, excuse me?
Shit, they're hard
She's
to
like,
do.
I don't mind the Wii because you're up and moving. It's not like you're sitting on the couch because that's what she hates. She thought kids didn't go outside and play and all this stuff.
She's sitting there with the headband on, like, let's go.
She is psychotically good at bowling. You have no idea. I think it's because she doesn't have vision in one eye, so we always say it's because she can line it up easily. I don't know, but she gets really mad when we say that, though. But yeah, no video games.
Yeah, my dad's not good at bowling. He's bowling to one eye.
He's not? Well, don't tell her that, because we still think that's our theories. But, okay, so my radius here. If I draw a radius, that radius of the circle is going to go from the axis to the curve. And we know from the axis to the curve is just the function, correct?
Right.
So in our case, that's square root of 3x squared, which is actually pi times 3x. You with me there? So now I'm going to integrate that. Now what I would always do, if it's always going to be a circle, I'm always going to have a pi, correct? I would always take it out. Now step 3 says I need to find my limits of integration. Well, here's the thing, guys, be very careful. I revolved about the x-axis, right? Which tells me if I revolve this way, I better be looking at the x-axis. So my limits of integration are 0 to 4. Does everyone see that on the x-axis? It's going to change here in a minute. Not in this problem, but I'm saying if I'm revolving this way, I better be along the x-axis. Because I think Tuesday, we are not revolving around an axis. We are revolving around a different line. Like an actual like y equals 2. And as long as you're going this way, you better look at your x.
What if it's like just like a diagonal line and it's like just y?
We don't really get into that into this type of calculus. Yeah, it's either horizontal or vertical. Yeah, but it's possible. It's doable. Yeah. Okay, so here we go. Very easy to integrate. My antiderivative is we have x squared from 0 to 4. Plug in 4. What do I get?
12.
20. What?
12.
I got 24.
Yeah, that's 24.
Okay. 16.
Yeah.
Did you do 8? Did you do 8?
Yeah, I did.
Mine's 0. So I end up getting 24 pi. Once again, this is volume, so it better not be negative. You definitely cannot have a negative volume. You messed up if you have a negative number.
Take up those space that exists.
Questions? Try a y-axis. These are a little tougher for some people. So we want the regions between the graphs. X equals negative y squared plus 4y. And the line y equals 2. divide by itself there. Unless you complete the square, which I would be interested to see how we remember that.
Yeah, I don't.
Yeah.
I didn't really get it the first time, he's trying to teach it to me.
That's easy.
Your
You have to remember. No, you guys, if I showed it to you, you'd catch on in about a minute. Everybody get that?
Yeah.
Now, on these little ones, we shouldn't really need a calculator anymore. Because we know it's a parabola flip down, which actually means this way when we're on sideways, right? And if I factor out negative y, I get y minus 4, so it's going to cross at 0 and 4, right? Just know that that negative means I'm going this way now. Positive means it's up. So we should kind of know what those graphs starting to look like in our heads. So I now have the line x equals 0, which is the y-axis, and y equals 2, which is right down the center. You with me there? So now the question becomes, which region? I want the one bounded by those three graphs. Wasn't that bounded by all three graphs? Isn't that bounded by all three graphs? Which one do I want to revolve? Not both,
The top.
because both would not be bounded by y equals 2.
The bottom. The bottom.
Change your mind? Not both. I already said not both.
The bottom one.
Yes.
Does it matter? Isn't this a parabola?
Yeah.
It's the exact same thing, correct? This chunk is the same as this chunk. It's a parabola split right down the middle. So it does not matter. Okay? If it mattered, you would be given more information. Yeah? So, it does not matter. Usually we stick with the easiest one, which is probably this. So when I revolve it, it's going to kind of be a symmetrical picture, right? See, I'm going to kind of have a bowl.
Yes.
And when I say draw a picture, that does not mean draw the area. No, no, no. It means draw the solid. So I see a couple of your papers that you only have the area drawn. I should see it reflected with those circles like I drew. I should not have a picture of the area. We are not doing area. We are doing volume. Once again, if I revolve the top, I'm going to get the same thing. So, I've got my picture drawn, which is sometimes the hardest part. Now I need the area function. Well, is pi r squared? But here we go. Or, we need to be careful. If we revolve this way, you better be in terms of y. Okay? So if I'm revolving around a vertical line, you must be in terms of y. Now it just so happens this one is in terms of y. And notice we're going from the axis to the curve. So that's just the function, correct? So don't assume, because sometimes you're going to have to change variables there. So my integral, I'm going to pull out the pi. Negative y squared plus 4y, quantity squared, dy. Now, when I find my limits of integration, I'm integrating with respect to y, so I better look at the y-axis, right? So I'm going from 0 to 2. The key thing is, when you're revolving this way around a vertical line, you better be all in terms of y. Just like our arrow, we went left to right, we better be in terms of y. So, let's do this. Let's distribute. minus 4y cubed. You're going to give me minus 8y cubed plus 16y squared. You with me there?
Yep.
Kind of foil just in my head. So now antiderivative is what? 1/5 y to the fifth. 2y to the fourth
16
plus 16
times y cubed.
thirds y cubed. Value from 0 to 2. Okay. So when I plug in 2, what will I get here?
8/5.
What?
Oh, sorry.
Come on guys, what's 2 to the fifth?
32.
32. What about here? 32. Well, that's what about here?
48.
That's 16, not 6, but
No.
that's 6.
That's a 16 from our problem above it, yeah. So 48, carry the 4. Get 128 thirds. And the rest are minus 0, right? Yes, no? Well, let's do some common denominator stuff. This one needs a 3 over 3. This one needs a 15. Yes?
Yep.
This one needs a 5. So 32 times 3, give me 96 over 15. See, 32 times 15, 10, carry the 1, 16, 0, 2, 3, 480 over 15. Then we have 128 times 5, 40, 14, 640. Just basic math, right? I mean, it takes a while, but it's just basic math. Okay. I'm going to add the positives. So I get 640 plus 96, 730. And then minus your 480.
736.
What?
736.
Oh, thank you. It's a 6. Thanks. That's a 6. 250. 256. Dang it. Gosh. 256 over 15. But let's see, does that reduce? Well, 5 won't go into it, right? Will 3 go into it? We have a shortcut to know if 3 goes into something. No, how do we know that? No, we don't need to divide. Come on, guys. You know this shortcut. How do you know if 3 goes into 256 without actually dividing?
You guys can fix 6?
2 plus 5 plus 6 is what?
13.
13. Will 3 go into 13? No, so we won't go to that. Remember, add the digits. Man.
I just think 2 doesn't go in, 2 goes into 240, and or 3 doesn't go into 16.
But if I give you a really big number, that's not going to work. But, and some of these guys, I will tell you this right now, some of these get nasty. You're going to get some big, weird answers. A lot of people second guess themselves. I have 256 pi over 15. Questions? And guys, theoretically, this could be a no calculator question, even with that graph. No? Question. Do you try? don't need a calculator for this problem at all. Semicircle revolving around the y, so it kind of creates a bowl, right? A solid bowl. Okay. Now, so pi. Here's the thing, though. I'm revolving around the y, and as I saw quite a few of you do. You've got to solve for x here. Now, it just so happens they end up being the same thing because it is a circle, correct? X squared plus y squared equals r squared. So they end up being the same thing, but you had to solve for y. So when I square it, I just get 16 minus y squared. My limits of integration, I have to look at the y, 0 to 4. Okay, do a little basic math, I get 128 pi over 3. Questions?